My name's Alec Kepner, and today I'm going to be talking to you about the Mill Creek watershed. More in depth today, we're going to be talking about the QHEI, types of land uses, as well as some of the water chemistry results, including specific red flags or parameters, if you will. So to get started, I'm a Master's of Science student here at Marshall University, and I am taking watershed management with Dr. Armstead. QHEI, under the Ohio Environmental Protection Agency, which is the official environmental state agency of Ohio. QHEI is a qualitative habitat environmental index. Essentially, this determines any water quality by utilizing the overall standardized qualitative habitat index. It's a physical habitat index that is used to provide the empirical and quantified evaluation of the generologic macrohabitat and are important to the fish communities. This is composed of 6 principal metrics and has a maximum score of 100, and each metric is scored differently and then summed for a total score. Each sampling site is typically done once a year unless special cases warrant. So essentially, any QA/QCs or standard operating procedures under the Ohio EPA QHEI most likely is going to be used. More specifically, here are the 6 QHEI metrics. So the first one's a substrate. This includes the substrate type and substrate quality. The second one is in-stream cover. In-stream cover is the types and amount of overall in-stream cover. Channel morphology is number 3. Quality of the stream channel that is related to the creation and stability of the macrohabitat. Number 4 is the riparian zone and bank erosion. Quality of the riparian buffer zone and the quality of the floodplain vegetation. 5 is the pool, glide, and riffle run quality, essentially the quality of the pool, the glide, or the riffle, as well as the run habitats. And last but not least, number 6 is the map gradient, local or map gradient calculated from the USGS 7.5-minute topographic maps by measuring elevation drop through the sampling area. So briefly, just to orient yourself, the Mill Creek watershed is primarily throughout Union County, Ohio, which is just northwest of central Ohio. Marysville is the biggest city in population as well as size in this area. The majority of this area is rural and agriculture. So you can see by the description and the key that you can see a little bit of deciduous forests and open water, and the rest, as you can see, is mainly cropland. Ohio EPA, so essentially the biological and water quality study of the Mill Creek watershed. This report was done and did samplings in the year of 2009, 2012, and 2013. 4 streams in the Mill Creek watershed were evaluated for aquatic life and recreational use potential. 11 sites were measured for E. coli in Mill Creek, which I thought was worth noting, and the water chemistry and other assessments were evaluated to determine the habitat and any degradation to the habitat. So water chemistry's results are based on the Ohio Water Quality Standards, OAC 3745-1 criteria. Metals, total dissolved solids, TDS, and anaerobic nutrients have been linked to the degradation of aquatic biological communities, especially nitrate plus nitrite and total phosphorus. Water samples were collected at a total of 29 locations throughout the Mill Creek stream and larger tributaries. You'll be able to see this in Table 1. So Table 1 is essentially the station and the names, and it lists the coordinates, locations, as well as the basin and stream. So as you can see, also to the right, it lists what was sampled and what was detected. So you can see for trib is tributary, RM is river mile, lat and long stands for latitude, longitude, and F is for fish, etc., etc., etc. To cap off the water chemistry, the results from the Mill Creek area, the water samples, again, I can't stress this enough, were from the 29 locations, and the surface water samples analyzed for the following: common metals, nutrients, bacteria, pH, temperature, alkalinity, conductivity, suspended and dissolved solids, chemical oxygen demand, dissolved oxygen, and percent DO concentration. So if you look at this stream discharge, if you look at the hydrograph, it goes through several months spanning from May to October. And you can see the daily flow, the water chemistry markings, and the daily mean flow. And the daily mean flow has spanned a total of 68 years for the mean. Categorical samples, we're using temperature, pH, conductivity, and dissolved oxygen. And here's a look at our sampling table. Again, to the left you see the locations, and to the right you see the quantified data. So what does all this mean? So with all the tables and numbers and figures that we just looked at and evaluated, temperature. So the creek is small and a shallow stream. This results in rapid temperature fluctuations. So essentially, if you have a cold winter's day, it's going to be impacted a lot greater in temperature when compared to, let's say, a huge river like the Ohio River, where the Ohio River, for example, can span half a mile wide and in some places 200 to 300 feet deep, whereas this stream's about 5 to 10 feet wide and it can be less than a foot in some areas. So you can see the difference on temperature inversion. So essentially this displays the potential to exceed temperature criteria when nearing the summer and low flow critical conditions. pH for the streams was observed and no exceedances were observed. Conductivity, so this was greatly increased in parts of the stream where the wastewater treatment plants were located. This was proven by the table where the location sample was collected from the Marysville water plant. No violations were observed, but it does act as a good indicator of the changes in water chemistry. Also, dissolved oxygen, DO. All the tributaries except for the Blues Creek failed to results that failed to meet minimum and average dissolved oxygen criteria for 24-hour cycles. These tributaries were monitored because historical impacts have occurred in the past. DO was sampled during the samples conducted at each specific location. The main stream of creek was well performing overall and holistically. Organic enrichment was detected downstream of the city of Marysville, and ranges were allowing potential of algal production. The DO minimum appeared to be buffered by the Marysville wastewater discharge plant. Recreational use. So there's not too much, but we still have to test for it. But occasionally you'll get the occasional water skier or just the occasional swimmer. So the water quality is going to be under the Ohio Water Quality Standards, Table 7-13, and the OAC 3745-1-07, based upon the presence or detection of bacteria indicators in the water column. Stream making up Mill Creek were evaluated and designed as a primary contact recreational use, stated in the following OAC rule. And the water bodies classified as PCR is quoted as being waters that during the recreational season are suitable for one or more full body contact recreation activities such as, but not limited to, wading, swimming, boating, water skiing, canoeing, kayaking, and scuba diving. Again, this is under OAC 3745-1-07 B4B. Again, this area, occasional water skiing, but primarily it's going to be boating as far as canoeing is, and the occasional swimmer for this area. Here is a map that was utilizing GIS software that shows the full attainment, non-attainment, and the boundaries of the Mill Creek watershed. Sediment testing, so essentially collected from the 4 sites within the Mill Creek study area, collected in the year 2012, 2 inclusions on the Mill Creek mainstream in 1 site and crosses run near the mouth, and 1 in Blues Creek near the mouth. Each site was measured for nutrients, total organic carbon metals, and 130 organic parameters, including polycyclic aromatic hydrocarbons and polychlorinated biphenyls and various pesticides. Keep in mind the use of pesticides, herbicides, and insecticides is going to be very high in this area because this county is primarily agriculture, as well as farming. Metals in the creek. So here we can see under Table 17, this just shows the results of the chemical and physical sediment testing of this Mill Creek study area. This was done in the year 2012, but it was compared to the guidelines of the 2000 in the 1993 McDonald edition. Essentially, you can see down here in the year 2012, the select dashes, it shows the types of exceeds from concentration or the exceeds of severe effect levels, which you can see throughout the X and Y axis. The parameters such as the metals, such as aluminum, arsenic, barium, etc., are located in the parameter column. So here are impairments, obviously. The blue, yellow, or the green, as well as the red, show the different levels of impairments, red being completely impaired. As you can see, there were over 5 samples that did show that were impaired, according to the QHEI. QHEI did give a poor score of 75 and 50s on some of these. Again, the sources for the impairment come from agricultural, the sediment, and the contaminated sediments. Channelization, illicit discharges also were factors in some of the location areas. So what does all this mean? Again, impaired locations are labeled in the red color. 5 of the 16 locations were deemed impaired or poor due to the low QHEI rating. So remember, when you see these scores, it is out of 100. So if you're seeing low scores, odds are your stream is going to be impaired. Caused by sedimentation, the source, again, is caused by agricultural usage. Other main impairments involve direct habitat alterations. The source of this is from channelization and illicit discharges. QHEI for poor streams was around 50 to 75%. Macro narrative was rated as poor. NPDES, National Pollutant Discharge Elimination System, so 13 individual permits were used for sanitary water and industrial processes. City of Marysville Water Reclamation Facility is the only major NPDES facility in the study area, and the parameters of the study was monitored to include the temperature, pH, conductivity, and dissolved oxygen. As you can see through Table 13, I have displayed the NPDES permanent monitoring from the EPA link, and it's just a summary of all the data that was collected in the year of 2012. Again, it shows the stream name, river mile, as well as the temperature, pH, conductivity, and dissolved oxygen measured in milligrams per liter. And thank you for watching this slide, and my sources are listed as follows.